Hi guys, my name is Jason Zaman. I am the data engineering manager at Xometry. My talk, as you can see, is called Using Data Pipeline Contract to Prevent Breakage in Analytics Reporting. Just rolls off the tongue. But I hope it's descriptive of what I'm going to talk about in the problem statement. A little bit about Xometry, the company that I work for. We are an integrated solution for buyers and suppliers for custom manufacturing. We provide a marketplace where people from the medical space, consumer products, or anyone like on a hobby puts out what kind of part do you want. You can upload a CAD file, and then in our marketplace, we match you up to our suppliers. Within the United States, suppliers across the world, from people who are running mom and pop shops to really big industrial manufacturers. So our algorithm matches you up to that, and my job is to make sure that all the data doesn't break. So how do we do it? We have our own AI algorithm. It's a machine learning algorithm. You go to our website, you put in a CAD file, and based on the machine algorithm and the file and the part and what kind of finish and color you want, we give you an instant price, instant quote, and options of how fast do you want it, and from there you also get quality control and a reliable set of partners who can make the parts for you. Here's the problem that we dealt with. The AI pricing models, quoting models, shipping models that we used are directly dependent on the data that we ingest into our data warehouse. Our data scientists and machine learning engineers and our ops folks use that data to train the models that are used for that very fast quoting and shipping and pricing engine. So whenever developers made any upstream changes in our main databases or microservices, we would have delays because we wouldn't know what went wrong. Not every change was destructive, but it would cause a lot of problems. Not only that, so that's the core of our business that got affected, we also had downstream reports that broke that my CEO, my CFO would say, hey, this liquid report that I look at every day to make sure that our quotes and orders are correct are broken. This, back in the day, let's say 2021, would happen like twice a week. On average, it would take about 2 hours to diagnose and resolve the problem because we wouldn't know where the problem was coming from. Not obviously every problem has its own specifications, but it took us a while to diagnose the problem and fix it. Now, here is what we were dealing with at the time. Our software development team, for the most part, they use what you see on the left side of this diagram. They use GitHub and GitLab for their CI/CD pipelines. They use Node.js and a Postgres instance for deploying, for writing their code and storing it in a database. And then they would use Docker and on top of it, Kubernetes to deploy. We, on the data engineering side, would use Fivetran to ingest the data from the Postgres layers, put it into our Snowflake data warehouse, and use dbt to transform the data. And then this is probably the one that you guys might not be super familiar with. We use select star to identify and make sure the lineage was properly graphed. I'll talk a lot more about select star in a second, but select star is a lineage tool that gives you insight not only of your dbt layers, it gives you insight of from your data warehouse to any downstream report that's in Looker, Tableau, Mode, whatever you use so that you get full visibility into your data lineage. And it gives you column level lineage, and we'll get into that. We needed to track our data back to the root cause of the issue. This was our solution criteria. We needed kind of a comprehensive set of solution. We needed a way to automate the process so that developers would know when they're publishing the data, they would know what it is they're affecting. And if they're changing anything, deprecating anything, deleting any columns, they would know what they were doing and what the impacts of it would be. It would need to be, I like this phrase, a native set it and forget it integrations. I couldn't ask developers to use a tool that they've never heard of. Instead, we had to work with the language and the stack they were working with and have a set of tools and process that they could easily implement. It needs to be high accurate. It needed to be high accuracy. Regardless of scale or complexity, it needed to just work. And it needed to be simple, intuitive. You didn't need to know the whole process and all of its in-depth layers, but you need to follow simple documentation to make sure the proper processes and lineage was set up so that you would not break downstream reporting. And lastly, we also needed, and they needed to know column level lineage so they understood if they changed one column, it would adversely affect downstream reports and downstream usages. Here is what our solution kind of architected itself. We call it DPICT. Don't Google this. This is a term we came up with. But I like this term because when you give a process a term, it gives it legitimacy. So software developers are now using my microservice is on DPICT. Well, it's not. I was like, well, that's the reason that it broke. So in general, their Postgres DB would be somewhere on, we use AWS to host our databases. It would get ingested using Fivetran. It would get dumped into our Snowflake raw database layer. And this part, Docker and source code, the source code is what manages the model and schema of their database. And this is where we would come in. We put in and created a Docker container that contains a couple of things, but the most important things are DBT and select star, which works seamlessly to whatever some teams use GitLab pipelines, some teams use GitHub Actions. Whatever CI/CD pipeline you use, we can accommodate. And it basically shows and prevents breakage at the source when you're trying to do destructive actions. And then lastly, it also not only does it do that, it helps the whole process. So if you want to get your data into already staged and ready to go to use, it also does that. It deploys the DBT stage layer right from your database, from your source code. We'll go into an example of this in a second. Here's another thing about select star. We deployed DPICT or set up the initial process, started iterating on that before we chose select star. But we were really searching for a column level lineage tool. We've looked at it. I know there's other sources. DBT has their own, but nothing really got to what we were needing, which is not only column level, but also integration with our reporting platforms, which is Looker and Tableau. They give us a good, rich API integration and support, which you're going to see in a second. And it shows you upstream and downstream impact analysis. Since adopting it, we have automatically detected and displayed accurate column level lineage, and it mitigates the issues and shows you the impact of the developer. It's when developers try to write some code and they get an error message like, oh, you can't do it. They're frustrated, like, what? Why not? This should be my source code. But it gives you the error message in context and shows you, here's what will break if you do this. So here's the nitty gritty. So I know you love me talking, so I was not going to do a live demo for you. So I videotaped myself.
This is a microservice we have set up. It's our own data engineering ingestion layer. And inside of it, we actually stage our data as a microservice. So we call it analytic schema models. And this kind of looks like a similar DBT staging layer. It has these fields. Now, what we've created is an ability to make sure that if any of these fields are impacted, software developers get an error. So here's a test PR right away. You can see I have deleted the event event field and deleted from schema. If you look at the current CI/CD we have with GitHub Action, it says that's a no-go. Look at the details. In the details, within the logs, it's right here. It says, seems your changes might be breaking. Follow this link for help. This is the Confluence document, so like why it might be. And to see the impact of renaming or deleting this column, which we've done, we can check out select star, which is what we have. As you see in Xometry services, that's our staging layer. Data engineering Dagster, it has downstream impacts, and it has two dashboards that depend on it. So a software developer would be invested in making sure that this doesn't break and it's automatically available. Along with this, we didn't just build a thing that breaks, but we also build a process that allows users to add a table very easily. This is done through a simple node module that we've created. We called it Postgres DE Analytics. And one of the commands you can add to it is add table to schema. It asks for a local Postgres database to be spun up. You pass in your credentials, and it says, hey, these tables have not been added yet. Which tables would you like to add? Let's say I wanted to add asset key. I go ahead and press space and enter. Boom, it's already there. If we look at the changes, it creates the DBT model and schema right for you, something that developers don't really have to do. They can just run our node module and it's all set up for them, and we'll be happy when it gets into our staging layer.
So you just saw the video of how the nitty gritty works. So a couple of things that might have been missed in some of the video is we use both GitHub Actions, CI/CD, and you can see right here in the two jobs that are highlighted, CI Analytics, that makes sure that developers don't break the data contract and the schemas they've entered with us and in DPICT. And the release analytics make sure that they are able to update whenever they need to, add a table, add columns, etc. And it's using, if you use GitHub Actions, it's just a bunch of script that you can copy and paste. And similar, if you use GitLab pipelines, which some of our microservices teams do, it follows a very similar process. And you can see, the run test pipeline and the validate schema works in a very similar way. And there's further down in there, there's a deploy production Snowflake analytics stage schema as well. Lastly, none of this works well without really great documentation. And, well, I'm a little biased, and I wrote this documentation. This is what we really got to engage with developers where they're at. Developers are comfortable following clear and specific documentation. And then in here, it has a step-by-step guideline of how to automatically keep your staging layers up to date. It shows you how to do it with whatever CI/CD tool you use. And it allows developers how to see the downstream impact if errors come their way and where to go for help. The results, we've had since 2021, 2 years ago, 14 plus microservices have been deployed. New fields and additions and changes get tracked automatically. So you'll see on the right side is a local report that we automatically generate. It's like, hey, last week, this was in September, these fields got added on the model. So it gives us some timeline to add to the model if it needs to be added. And also, basically, we went and erased a whole pipeline of area, a whole surface area when we're trying to debug data problems, and increase transparency, reliability, and speed. Just how much, you ask? This is how much. 200 plus hours saved for the data engineering team per year. As you saw the earlier slide, we're spending 2+ hours just diagnosing the problem and trying to fix it. Lowering the surface area problems, especially on the microservices layer, and where we had some control and we could give developers easy step-by-step follow-up process for the DPICT contract that we ended up with really helps with that. And lastly, now that we know that layer, or even the error messages that developers might come up with, it's more predictable. So we have a lot of easier time when things do break, and they do break. It's about 36 times faster, especially if it's on the upstream changes that developers are making. And this is my favorite part, which is 80% decrease in resources required to add new data sources. In plain language, that basically means it used to take about a week after you got your database to prod, which is a heroic effort, to get it into our Snowflake database and then add the staging layer. Now it takes a day. You want it, it's up in prod, you set up those scripts within the Docker container, and it's all ready to go. And that's my presentation. Any questions?